in hard water as soap molecules react with calcium. You see soap molecule. Here what they said, here it said about detergents do not form. They did not mention anything about the soap molecules. React with calcium and magnesium salts present. So the soap molecule will form, react with CaSO4, MgSO4, calcium, magnesium things, and CaCl2. Like this, it will form insoluble substances. These are scum. So, and scum is a precipitate. So it will form precipitate also. So that is true, but not the correct explanation. You can take the screenshot if you want. Now, next question. How would you name the following compound? See these compounds and try. Also, you have to name. This question is like name or give example. Give a name only. This question is name. Simple ketone and simplest alkene and simplest ketone you have to name. Okay. So before that, how would you name the following compounds? This one, and this one. So how would you name the following compounds? What is this? This one. I'll give an idea. It is ethyl bromide. Bromide. Okay. Bromide. Even it is called bromoethane. Bromoethane. Okay. Try this one. HCO and try this one. Let's see, can you do? Okay, your time is up. You want a few more seconds to do it? Fine. Only few more seconds. And it's up. This is methanol. Okay. Methanol. Because it is al means aldehyde. And this one is I'm telling 1, 2, 3, 4, 5, 6. So it should be hexane or something like that. Since it has triple bond, it will be hexane. So it will be 1 hexane. Now, can you guess what this 1 is for? Some students message me that they want this thing. They want the link for this live stream. So I'll quickly send the live stream link to them. Until the time, tell me in the chat that what do you think? Why this is this? Why is there? It's due to the triple bond. Okay. Now, let's go to the next question. So, are you ready? Seems like you are totally ready. Okay. So, this is the next question. Try this one. Name simplest alkene and name simplest ketone. Also, Lakshmi said that I have to explain the concepts, so I will explain the concepts along with that. Draw their structure. So you have to draw their structure as well. So try that for once. Simplest alkene and simple alkane. It is alkene. E is there. So in carbon, in methane, you can't form simplest one. Alkene means it should have carbon-carbon double bond. And here, since it is single carbon, it can't have. So it should be C2 like this. And then hydrogen H2, methane, ethane. So eth. So this is ethene. So this is simplest alkene is ethene. Okay, this is the simplest ethene. And simplest ketone, try to think of simplest ketone. We'll do the structure as well. So don't worry for that. So ketone has this functional group. Ketone has this C double bond O functional group. So C double bond O. This functional group is in the ketone, simplest ketone. So that should be propanone. So it will be CH3, and methane, ethane, propane. So simplest ketone is propanone. Okay, getting it? Now we have to draw their structure also. So this is the other one structure, like the basic structure, and yeah, basic structure done. That's it. I will show the, like, you know, the single carbon carbon and hydrogen hydrogen. So here it is. You can take the screenshot. This is one. Okay. What? Lakshmi still have a request. Let's see what she want to say. Okay. So you want to say something, Lakshmi? Where are you, Lakshmi? Hmm. Okay. Say what you want to say. Hmm. Oh yeah. Hmm. Yes. Why not? So homologous series, actually it is indeed confusing, and definitely I'll help you and I will explain. So in homologous series, there are a few functional groups like OH. Now, listen carefully. The thing I'm going to explain, homologous series, it is most of the, like 60% you can say of the this chapter. So you have to understand it. It's very crucial. Based on that, this, if you understand this, you can say the chapter you understood mostly. So let's see the homologous series. So here it is. Actually, functional group and homologous series both. To understand this, before that, what is the homologous series, that I will explain, so that you will get an idea. Because directly if you see this thing, you might get confused. So homologous, what do you mean by homologous? Homologous, let's move here and let's see. Let's say methane, ethane, propane. So CH4 methane, C2 H6 ethane, C3 H8 propane. Okay. So now these are all gases. All of these are gases. These are all flammable, or actually highly flammable. Means they burn in the air. Flammable. They burn in the air very quickly. So they have all similar properties. They are hydrocarbon. Okay. So their name also similar. Their properties also similar. So this is a homologous series. A homologous series is the hydrocarbon which is like family of the same member of the same family. Like these are all alkane group. Alkane group. Okay. Then there is also alkene group. I'll I'll use another color for alkene group, so you'll get idea, and so that you should not get confused also. So let's see alkene. Alkene group is, it doesn't start with meth, it start with ethene. So it will be C2H2, no, H4, ethene. Okay. Now why this ene is there instead of A? Because when you see its structure, it will be two carbon double bond and then two hydrogen single bond. Here also two hydrogen single bond. Okay. So that's why it is ethene. And then again here propene C3H6 and then C4H8. Okay. Just H2 P plus H2 keep on increasing. CH2 you have to keep on adding. You see here one carbon and two hydrogen added. Here also one carbon, two hydrogen added. So this is the basic of homologous series. There is also alkyne. Okay, so I will give one example of alkyne as well. So alkyne. Alkyne is ethyne. So C2H2, C3H4, C4H6, C5H8. Okay, these are all alkyne. Now I will show its structure. The triple bond, okay, not double bond, triple bond, okay. So that is the difference. That's why it is ine, and this is called ethyne. So it is called, its name is ethyne. Okay, now I will give you a formula so that every time you will understand how many atoms, how many carbon, how many hydrogen it will be. Okay, this is a hack, you can say. The formula, general formula: methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, all you will remember with that formula. Okay, so it's a super formula. Are you ready for it? You should say at least, yeah. Say that. Yeah, now you are ready. So let's carry on. Good, you are very responsive. The formula for this is CnH2n plus 2. Okay, now what is this CnH2n plus 2? Let's say n equal to 1, means 1 carbon. So C1, and here also n equal to 1. So H2 into 1 is 2 only, and 2 plus 2, 4. CH4, we got methane. Okay, try for, I'm trying for this one, you try for this one. So n equal to here n equal to 3. Okay, so Cn, C3, C3, H2 into 3 is 6, 2 into 3 is 6, plus 2 8, H8. That gives us this formula. Okay, so this is how this formula works. For this alkene also there is a formula, and that is Cn H2n. That's it. Plus 2 not required. Just H2n. Okay. If you still have doubt, you can ask me the doubts. And alkyne formula is general formula Cn H2n minus 2. Keep in mind. See here, hydrogen is drastically less, only 2, only 4. Okay. So minus 2. That's the difference between the formula. Now let's, if you want, you can take a screenshot of this thing. It can be very helpful to you. Okay, and then we'll go about the functional group and other things about that. So by the way, functional group. I think Lakshmi got idea about this functional group. If you also got, that's nice, but if you have doubt, you can explain. Now let's see how does this functional group work. Okay, which one is which functional group? So this one is for alcohol. Okay, and these are the example, like methanol, ethanol. This is ethanol. This one, propanol, butanol we can have. So butanol, and in butanol we will have this OH group in butane. So butane is what? C4. So C4, and H should be 9. So C4H9 OH. Okay, let's make this butanol. I'm going to make the structure of this butanol. So let's make the structure here. 4 carbon, 1, 2, 3, 4. 1 OH group. So let's attach 1 OH over here. OH, alcohol group. This is the important part, the alcohol group. Okay, this alcohol. Carbon, carbon, all single bonds. Then hydrogen, 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 hydrogen. Okay, and one more hydrogen over here. Now let's count. These are 4, these are 4. 4 plus 4, 8, and 1, 9, and this one is OH. That's the alcohol group, and that's how this butanol is. Now aldehyde, what is important in aldehyde is CHO group. Okay, can you say what is this R? This alkane group we have now, this carbon group, this one, this thing, this is R. Okay, R means any alkane. So in aldehyde, we have CHO, for example, let's say this one, methyl, okay, and then this is ethyl, so ethyl, ethanol, ethanol, actually ethanol, and ethanaldehyde you can say, or ethanol you can say. Aldehydes are the IUPAC name in ethanol. Aldehydes is ethanol. That's called the suffix. Meth is prefix, and al is the suffix, like what is in the main, what is the in the end, that is called suffix. Okay, so remember this, for you have to keep on practicing. For aldehyde, CHO, RCHO. For ketone, see the difference. In this one, in aldehyde, after it this CH3 there is CHO. Okay, but in ketone, after CH3 there is CO and CH3 again. Okay, CH3 and then in the middle. So this CHO or CO is in the middle. That is the difference. So keep in mind that thing. So it will be C uh, C double bond O, and then here R, that is one alkane, and here R. Like here in place of R, it can be CH3. Here also it can be CH3. I will make one propanone. I will make, or I can make butanone. Okay, so let's make butanone. Hmm. 1, 2, 3, 4. After 4, we have to have uh, 2 double bond, a double bond with oxygen, single carbon bond. Here H3, here H3, here hydrogen, here hydrogen, and yeah, that's it. So this is the butanone. Okay, this thing here. Okay, so that is the ketone. Now carboxylic acid. Carboxylic acid is important. It's ethanoic acid also, and acetic acid, vinegar is that only. This is vinegar. Okay, carboxylic vinegar is carboxylic acid. So keep that in mind. Now, what is this carboxylic acid? Carboxylic acid. And what is in this carboxylic acid? First is methanoic acid. Its functional group is not, earlier you saw first it started with OH, first for alcohol. For aldehyde it was CHO. For ketone it's carbon double bond with oxygen. Okay, and it is bonding with two side. You see here, one side alkane and other side alkane. In carboxylic acid it's COOH. Okay, the vinegar. So HCOOH, methanoic acid, or vinegar, ethanoic acid, CH3COOH. This is our acetic acid or ethanoic acid or vinegar. Okay, CH3COOH. Now just to replace this CH3, and you will find another one like C2H5COOH. This is the main thing. Okay, the functional group. Halogen is very easy. Okay, just to replace, you see halogen, how very easy. I'll say, where is there? Let's make methane here. So I'm making methane, CH4. Okay, now let's make it halogen. Means uh, yeah, let's react with halogen. So let's make it methyl chloride, CH3Cl. That's it. One hydrogen. See, I'm making the structure. General methane will be like this. Okay, in the halogen, one hydrogen will be replaced. So let's replace this guy with chlorine. That's it. Methyl chloride, done. That much easy. Halogen is very easy. Just replace one hydrogen with halogen. Wait, what is halogen? A few group in periodic table are called halogen. Like bromine, chlorine, iodine. These are all halide halogen groups. Okay. Now amine. Amine has, instead of oxygen, amine has NH2. Okay. Methylamine, ethylamine. That is, it doesn't come that many time in the exam, but it's good to know. Nitro, this is the nitro group. This ester comes in the exam. Okay. These halogen, these all comes in the exam. So ester. So in ester, it will be uh, RCOOR. Okay, this is the functional group in the ester. Double bond will be there, and then again one alkyl group will be there. That is the difference between ester. So for example, here you see COOCH3. Okay, so this is ester. So in ester, you will always have this group, this functional group. So methyl methanoate, ethyl ethanoate. This ester, they will ask the properties of the ester. Okay, did you get that now? Lakshmi, what about you? Did you get that? Seems like she got it. So we'll have some reaction and then we'll see what Lakshmi want to say about that. Where's Lakshmi? I will bring Lakshmi. So, and then I'll tell about that, what Lakshmi want to say. So did this thing, this functional group and all, did it make you sense, Lakshmi? And did you understand? Then we'll have allotrope of carbon also. So it seems she can. Yes. Hi, Lakshmi. So let's see. It seems she made a song. Okay. So let's let her continue the song. Good, Lakshmi, for the song. Hey, it's nice, Lakshmi. Ethanol. They pray the same God. Nice. Well done. We should actually clap for it. Yeah. Very nice, Lakshmi. Good. Is skilled. Hmm. Okay. It was nice. Good. Very good. I enjoyed it. So yeah, that's nice. Now after that, let's go to the next question. Oh, these are the question which are competency based question and that also confuse the students. Let's see how can you solve it. Pooja knows that water is universal solvent. She tried to dissolve an ester in the water. So Pooja tried to dissolve ester in the water, but to her surprise, it did not dissolve. Give reason why ester did not dissolve in water. Okay, so see, I will say, can you say actually? It is understanding based question. So try once. Understanding, you need to know what is the ester, what is its property, and why it doesn't dissolve in water. So I will tell the answer. The thing is, you see, water formula is H2O. So H2O, in which the H will have slightly positive charge and O will have slightly negative charge. That's called polar. So water is slightly polar compound. Means it will have slight charges. Okay, where ester is non-polar and that's why it won't dissolve. I'll show you the exact answer so that you will have better idea that what happened and why it did not dissolve. I already said. So still I'll try to answer it. So here's the answer for this question. Okay. Water is polar compound, whereas ester is a non-polar compound. And that's why it doesn't dissolve. Polar and non-polar I already explained. Okay. Now let's see some reaction of carbon and its compound, and let's see how does it whether it dissolves or not dissolve. After that we'll see this question. What is the question of Akanksha? She went to Chicago, USA in the month of January, meet her brother who works over there. She learned that her brother has used a mixture of alcohol and water. Yes, that's a nice competency based question. We'll see that also. Okay, so let's do that reaction. Let's see how does alcohol or carbon compound react with other things, other material. So we got into 3D simulation, and let's take a carbon compound. Let's see what carbon compound is available. Okay, so what I will do is I will take glucose. Sugar is also a type of glucose, so let's take that one. And let's act with an acid, but this time it will be a different acid. You see CH3COOH, first one, acetic acid. Earlier I gave that example, so that one is this. Okay, let's put over there and let's see how does it react. It's vinegar, by the way. It immediately dissolve and you can see these fumes coming. Okay, nice fumes coming. So these nice fumes are due to this reaction. Here is, oh, no reactions yet. What? Okay, it just to get dissolved. So what we'll do is we'll put some base and see does it react. So ammonium hydroxide, calcium hydroxide, that is asked in the exam mostly. Let's put that one. And now let's see what reaction is this. So this is the reaction, and the acetic acid reacted with calcium hydroxide. Now let's have some more reaction, but this time we will have with ethanol. So let's get ethanol. Ethanol is ethyl alcohol. And let's put some neutron material in that. What I will put? Which one? You people suggest me. Let's see does it react with zinc, which is reactive, but let's see does it react. It doesn't. Let's try. Okay, so zinc and ethanol both are burning. This one is very good. I like this one. Now let's take one more. Ethanol. And let's take this time calcium, and let's see does it react. It's not reacting. So let's put some acid so that it will react. Selenic acid, chromic acid, boric acid. And more. Let's try to burn it. Okay, we can see green flame. Wow, it's nice 3D. Anyway, so that's these 3D will do more in a while, but before that let's continue with that answer. So let's see this question's answer and how is it. So can you solve this question? Try that once. So in this question they are saying that Akanksha went to her to meet her brother in Chicago, USA, and she finds that her brother use a mixture of alcohol and water instead of only water in the car radiator. Okay, so yeah, she is anxious to know why the mixture of ethanol and water is used. Okay, can you answer it? There is a clue. I will give a clue about that. It is temperature is very low in Chicago over there, generally, comparatively, actually, and especially compared to Bharat. So can you guess what would be the difference? It is a nice question they can ask in the exam. You must know it. Check once, try once. Okay, I'm answering. The thing is, alcohol, let's say C2H5OH. It actually has low melting point. Okay, very low melting point. So even though water freezes in 0 degree, if you mix alcohol in water, it won't freeze, it won't become ice, and car will work nicely. That's the answer. Okay, so I'm gonna show you the answer. You can note it down. So here's the question answer for Akanksha's question. Here, a mixture of alcohol and water is used instead of water in radiator of vehicles in cold climate. We know that water freezes at 0, but ethanol added to water does not freeze. Got it? So now let's move to the next question. Give a test that can be used to differentiate chemically between butter and cooking oil. Now think, butter and cooking oil. Butter is good, cooking oil is used for cooking, and we know we can see them. But what test will you do to find out? If they ask this thing in your exam, what you will do? So can you guess? Okay, so the thing is, you should take a sample of either butter or and cooking oil both, and you should try to add bromine in that. Okay, Br. When you try to add that in cooking oil, it won't get reacted. But if you do in if you do that in cooking oil, in butter it won't react, but in cooking oil it will react. Hmm. Let me think that. Yes, cooking oil, there will be an example of cooking oil. Let's say ethene. So CH2 double bond CH2 plus Br, bromine. And this is an addition reaction. When you add this bromine into that, the bromine will get added. Okay, and you will get CH2 Br, that is bromine, Br or CH2 Br, bromine. I will show the exact answer, and if you still have doubt, good evening. Tell me your name. It's Sai Vaishnavi Tivia. I don't know. So good evening. Tell me your name. Anyway, so let's see that answer. So here is the answer. Take a note. Here is the full explanation. It is the same thing what I explained just now, and it is that. Then we'll see one more question and try to solve that one. In this chapter, first of all, this is one of the most confusing chapter. But if you do this one and understand the concepts, as Lakshmi asked before, not just in 10th class, but in 11th and 12th, if you take science, especially chemistry, it will be a very big help to you. It's double, triple benefit actually. Okay, so this is the solution. Now let's move to the next question. The structural. Oh, the structural formula of cyclohexane. Isn't it this kind of question give you a headache? Just a try. I'm going to tell, but try. Okay. And instead of getting headache, we must be laughing. Okay. So that we will be able to solve it nicely. Try once. Don't worry. You can do it. Earlier I explained IUPAC name. So after this, I will ask Lakshmi, what did you understand? Okay. Don't miss it. What Lakshmi is going to tell, don't miss it at all. Let's see. Now I'm going to answer. Your chance is done. I will give a few seconds more and then you have to tell. The moment the clock finishes, I will tell the answer. Your time will be done. And your time is done. Now, in this, the structural formula of cyclohexane is cyclohexane. Cyclohexane means all carbon, 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 but this is not cyclohexane because A is there, means all carbon, carbon, single bond. Where is the all carbon? Here. Here we have all carbon, carbon, single bond. And hexane means 6. So B is the correct answer. That's it. Okay. Cycle means it will be like just a ring like circle like structure. Okay. So this is the correct answer. Keep in mind. Now let's move to Lakshmi and let's see what she's saying. Don't miss it at all. It's next level thing. So Lakshmi, earlier I said IUPAC name. So can you tell what is this IUPAC name? Naming and system. Can you explain me? Earlier you sang like rap song, but it was not actually like singing. So can you do like singing? Try once. Wow, nice. But Lakshmi, I want you to start it once again. Okay, because I think the sound was not audible at that time. So it was my fault at that time. So I will make your sound clear. Oh, sound was not audible. I missed it that much. Nice. Anyway, now I think your sound is audible. So can you say now, Lakshmi?
Yeah, it's just a game. Let's go. Don't let the name freak you. Don't get the fear. Just follow the rules. I'ma make it clear. Step 1, find the longest chain. That's the parent. Count the C's, meth, F, prop, be a parent.
Nice.
Find the extra bit, the functional group. Is it O, L1, or an O inclin? Give it a number, the lowest you can. That's the IU pack hack. You're the master man.
IUPAC name. So your lyrics, I'm going to show them.
Don't get the fear, just follow the rules. I'ma make it clear. Step 1, find the longest chain. That's the parent. Count the C. Yes, prop, be a parent. Step 2, find the extra bit, the functional group. Is it O, L1, or an O glue? Step 3, give it a number, the lowest you can. That's the IU pack hack. You're the master man.
Very nice, Lakshmi. Super. I like it. Awesome. It really made sense and I like it a lot. Okay. Now let's go with the next one. Next question. So we solved that question, and earlier what Lakshmi said you could not hear. So I will make her speak again. So I will ask in a while about that again. But before that, let's see the next question. Keep in mind this question was asked in CBSE 2024 exam. Now combustion. 4 combustion reactions of carbon compounds are shown below. Here methane plus oxygen, here CH3CHO, it seems ethyl alcohol plus oxygen, and these are all. What can be concluded from the 4 reactions? All carbon compounds release oxygen on combustion? No, wrong. All carbon compounds release water on reacting with oxygen. Seems like yes. All carbon compounds produce carbon dioxide on reacting with oxygen. Second and third seems to be true, but which one is actually true? Can you tell exact one? So the thing is, see here, we are seeing carbon dioxide and water and heat. In all this we are seeing. Okay, so from that we can say second and third is the correct one. Okay. So it was nice. By the way, Lakshmi, your singing was very nice. I like it a lot. Yes, we should clap for it. Okay. So, done, done. Nice. Now, let's go for the next question. By the way, what I did just now? I don't know what I did just now. Identify a group of the unsaturated hydrocarbons from the following. So, a group of unsaturated hydrocarbon from the following. So, propanone, ethene, butanon. Try to find group of unsaturated hydrocarbon. Carbon, no, carbon. So, hydrocarbon from the following. Oops, I'm hearing my own sound. So let's just carry on this question and this thing. Identify group of unsaturated. Propane. Propane is unsaturated. I'm giving some chance to you people. Try once. Okay, done. Now I'm solving it. Propane unsaturated. Propane, it's saturated. Wait, what is saturated and unsaturated? I will tell that to you. See, C, carbon, 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 hydrogen, hydrogen, hydrogen. Okay, this is methane. Here you see all valencies are fulfilled with carbon. Now here you see carbon, carbon, double bond, hydrogen, 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 hydrogen. Do you think more carbon, more hydrogen can fit over here? Yes, it can. I'll show you. We can have one more hydrogen over here and one more hydrogen over here. Okay, and you see we added. So earlier when it was this one, like this, it was unsaturated because carbon-carbon double bond. So wherever there is carbon-carbon double bond or you can add extra hydrogen, that is unsaturated. So propane is there. It is alkane with carbon-carbon single bond. Ethene, again it is double bond, but here it is single bond. Cyclohexane, it is also single bond. Butane, ethene, propyne. There is no single bond or double bond or triple bond. So this is the correct answer. Okay. Are you very happy with that? Yeah, nice. So let's start with the next question. Okay, ready? You're laughing. Let's get ready for the next question. Methane, ethane, propane. So propane, this one belongs to the homologous series of. This one I'm not telling, okay, because I already explained about that. So you have to tell. Alkane, alkene, alkynes, and cycloalkanes. I'll give a clue. C3H8. So you have to draw 3 carbons. I'm not going to tell the exact answer, but I'll give a clue. 3 carbon and then 8 hydrogen. So 8 hydrogen. Here will be 3 hydrogen. Here will be 3 hydrogen. Here, here, here. Yes, 8 hydrogen. Okay. Or CH2 you can write here, your choice. Here you can write CH2. Okay. So it's C3H8. All single bond. Which one among them has single bond? That's it. Okay. So these two are wrong. One of these is correct. That much clue I'll give. You have to answer in the comment. Now, a compound X is an odorless means no smelling, liquid that is used as solvent, sweetening agent, and also as medicine. It is also a byproduct of the soap industry. Identify the compound X. Yes, this is a challenging question. And can you solve it? Try once. So here I'll say the answer. Just guess one. Is it glycerol? Is it glucose, ester, or propanol? Your time's up. Correct answer is glycerol. And the reason behind it is glycerol is a byproduct of the soap industry and is an odorless glycerin. Does it smell? No. And it is used as a solvent, sweetening agent in product. It will smell like sweet. Now Lakshmi liked it a lot, so she want to sing another song about carbon, but she want to ask me something. She spoke earlier also, but we did not hear. So let's see what she want to speak. By the way, before that, try to guess the answer of this question as well. Okay, till Lakshmi comes. Okay, so Lakshmi, you can say what you wanted to say. You came. Good. Hi.
Sir, you don't know how big favor you are doing for me by
Oh,
solving
really?
these competency-based questions.
Uh-huh.
But sir, I have one more request.
Okay.
This chapter shakes my brain more than the autos on our roads. So
What?
please explain the concepts also related to the questions.
Autos, more than autos on the road? What? Yeah, autos on the Indian road, they shake a lot. Yes. Earlier, she said that only, but we could not hear it. That's why I asked her to speak that again. Now, anyway, so try this question once. Can you get the answer for this question? Ethanol reacts with sodium and forms two products. These products are sodium ethanoate and hydrogen, sodium ethanoate and oxygen, sodium ethoxide, or sodium ethoxide and oxygen. So try once. So let's do that and let's try to find it out. First of all, we need to have ethanol. So I'm going to solve it. Ethanol is C2H5OH plus Na. It should give us C2H5ONa, that's sodium ethanoate plus hydrogen H2. Okay, so C is correct. This is the answer. It gives us sodium ethanoate, sodium ethoxide, because oxygen also here and H2 hydrogen also there. So that's the answer, sodium ethoxide and hydrogen. Okay, so let's see some chemical properties of ethanol. And before that, do you know one very big question and very big property of carbon? As you earlier request, I should explain some concepts. So tell me why carbon forms homologous series and why carbon itself has entire chapter. Is any other element has chapter in 10th class to you? No, na? So why carbon? There is two clue. I'll give you clue. One, its property of catenation, and second, its tetravalency. Okay, before going ahead, I will try to show, because I'm doing so many things at a time and sometimes these things are not working. So that's why I'll still try to show. Let's see. Yes, here it's working currently. So you can see here it's carbon's property, and carbon can form allotropes. See here, it is the diamond. Okay, carbon can also form this another hexagonal Buckminster fullerene. Okay, football like one. And then again your graphite that you use in your pencil, Okay, in your, this is not pencil, this is my tabs pen. So graphite will have layer by layer, see here, and that's why it breaks easily. It doesn't have that kind of bonding. That's the thing about it. Okay, so can you tell why the carbon, it has this catenation property, and why does it, how does it have the property of this tetravalency? What is this tetravalency? See, from earlier I am doing this thing to you people. I am making the carbon structure. One more time I will show you so that you will get clear. So let's go to the browser once again, and I will show that one. See here, carbon. These red one represents carbon, and the dark gray ball represent hydrogen. Okay, so it has 4 valency, that is tetravalency. Okay, it can bond with 4. And another is catenation. I'll say catenation also. The thing about catenation is carbon can react with carbon. It can make carbon carbon long chain, carbon 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 long chain, and it has a single carbon has tetravalency, means 4. Why does it have carbon tetravalency? Carbon's atomic number equal to 6, and configuration, atomic configuration equal to 2 comma 4. See these 4 outer electron. So how it will form? Actually carbon will be, I will try to make the simple one. Let's say it is the nucleus with this is carbon with proton and neutron, both will be 6 6. So let's say this is the first shell, 2 electron, and the second shell with 4 electron, 1 2 3 4. So this is tetravalency, means it can combine with 4 more elements. Let's say here is hydrogen, and here is 1 electron, here is 1 more hydrogen, here is 1 electron, but it can also combine with other carbon. So here it can be 1 more carbon and 1 more, and like that it can keep on going. Okay, so carbon this way can make long chains. So this is catenation, carbon carbon bonding, catenation, and its 4 valency, these 4. You know what is this line? This line represent this electron. You know, one electron is there, they will bond with another electron like this. So this bonding is represented by that line. Okay, if you still have any doubt, you can ask me. Also, earlier I said Lakshmi understood, so she wanted to tell about this. So I'll bring Lakshmi, and Lakshmi will tell about that. So Lakshmi, you are ready? What you wanted to say? Before going to what she want to say, take a look at this, and if you still have any doubt, you can ask me question regardingly. So carbon carbon tetravalency, and Lakshmi came, and she will say what she wanted to speak. So she's there. Are you there? Yes. Okay, you can say what you wanted.
Yo, yo, check
Huh?
the mic, CARB.
Wow.
Four hands in the air, that's tetravalency.
Tetravalency. Okay.
It's a covalent party. It bonds with
Where is that tetravalency?
self-love chain, call it catenation. It's running the game. Long chains, branch chains, even in a ring, that's why carbon is the undisputed king.
Nice.
From the diamond in your chain to the pencil in your grip, it's all just carbon, that's the hot tip.
Oh, very good. I want once more. It was nice.
Yo, yo, check the mic, CARBON. Four hands in the air, that's tetravalency.
Tetravalency. 4 hand means 4 valencies.
Covalent party.
Covalent bond.
It bonds with itself, self-love
That is
chain.
catenation.
Call it catenation. It's running the game.
Wow.
Long chains, branch
You are very
chains,
nice.
even in a ring, that's why carbon is the undisputed king. From the diamond in your chain to the pencil in your grip, it's all just carbon, that's the hot tip.
Wow, nice. It was like super duper ultra next level. I love it so much. Okay. Very good, Lakshmi. This is called hard work. Okay, so this is how we should study. Anyway, let's go to the next question. By the way, that is beyond expectations. So let's go to the next. Hey, how much clapping you people want? How much excited you are? Stop it. Anyway, so let's go to the next question. This one is done. This one is done. This one is done. Yes, chemical properties of ethanol. Okay, if you know this one, a lot of carbon idea you will have. So I'll quickly explain. Combustion, that's simply burning. Okay, how does ethanol burn? So it is inflammable, like ethanol, methanol. Wait a minute. What if I burn in front of you? I'm actually going to burn in real ethanol. Okay, just wait a second. This is don't do at home at all. Okay, so I'll actually show my background so that you will be able to see this burning thing. I'll remove my background completely so that you'll be see, and then I have never done this before. Okay, so I'm going to do that completely. Okay, now this is my background. This is the normal one, and that is that one. And yeah, that's that background. So here normal one is good. That one is like too much. That is also okay. This also looks good only, not that bad. But now it's good. Now it's clear. Yeah. Anyway, so I'm going to burn it in front of you. I took this lighter. Okay. Don't try at home by mistake also, because it could be a big mistake. So let's see its dangerous thing. So oops. Okay, so it's highly flammable. Don't try. Okay, I know it, that's why I tried, but you don't try. So anyway, let's carry on with this thing. Let's see how did it work. Yeah, it seems it worked nicely. And then let's remove the background as before. Yes, it's kind of working. Nice. And I've shown that. And I've shown this thing also. Now let's see the other property of ethanol. Reaction with sodium. So if ethanol reacts with sodium, it will form sodium ethoxide. Okay, it burns. Oxidation. So oxidation means addition of oxygen. So in the presence of potassium permanganate or KMnO4, one more oxygen will get added and it will form ethanoic acid, CH3COOH it will form. Next is dehydration. Dehydration means removal of oxygen or removal of water itself, you can say. Dehydration, removal of water. So when you heat ethanol at 443 Kelvin, in the presence of acid, okay, excess sulfuric acid, then some of water will be gone. See here, there's nothing else, only sulfuric acid and high temperature, and you see it became ethine. So this is how they produce ethine, and water is gone. Now esterification, it get transformed into ester. So there is this ethanol. Where is ethanol? This one, ethanol. Okay, and then they reacted with one carboxylic acid. This is carboxylic acid. This is ethanol. These two react, and water will get released. What we'll get new is ester. Ester is a sweet smelling substance, like artificial sweetener, artificial products, flavors. These are made with ester. This is ester. Next is saponification. Saponification means simply soap will get added, sodium will get added. So ester is treated. This is ester, this one, and in this ester, this CH3COONA, CH3COONA. So this C2H5 will be removed and Na will be come here, here. Here C2H5 is gone, okay, and Na got reacted. So this is esterification reaction. Now, alcohol is why very dangerous and very dangerous. Here, some effects is given when large quantities of ethanol is consumed. It tends to slow down the metabolic processes. Okay, it depresses the central nervous system, but that doesn't mean the drinkers got depression. They go in the depression when its effect is gone. But you know what? It will dissolve the brain. Like when you use so much of sanitizer, what happens to your hand? It starts burning if you use too much. So that happens to the brain also. This results in lack of coordination. They can't talk properly, they can't walk properly. So that thing occurs, and the individual may feel relaxed but does not realize that his sense of judgment, sense of timing is out of order. Okay, so that one. Now let's see the next question and let's see who can answer it. A carbon compound A having melting point 156 Kelvin and boiling point 351 Kelvin with molecular formula C2H5O6 is soluble in water in all proportion. So it is soluble in water in all proportion. Identify A. So A is soluble. Draw its electron dot structure. Give the molecular formula. It was asked in 2022 in sample question paper, but what was asked in sample question paper similar to that has been several times repeated in the exam, and since you have to write 2026 board exam, you must be prepared for it. So guess it, just guess it, don't worry, just it can be easy, it is not necessarily very hard. Just try, don't give up, once try. We actually just not talked about it. Okay, A is having high melting point, not very high, like 156 Kelvin is not high. Boiling point is very normal, 351 Kelvin. Molecular formula C2, molecular formula is already given. Okay, it's soluble in water. So I will give answer. C. Is that thing? C2H5OH, which is soluble in water. Soluble in water, they said. Also, they said it has a melting point of 156 and boiling point of 351, and this C2H5OH. So it is ethanol, C2H5OH, which is ethanol. Okay, and identify and draw its electron dot structure. So 2 carbon. Carbon will have single bonds. So this one. Then hydrogen. So hydrogen, 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 hydrogen. This is the electron dot structure. Then here it will be like oxygen. So oxygen, hydrogen. Here also hydrogen, and here also hydrogen. That's it. Actually, I will show you the simpler one, electron dot structure, ethanol. So here is the electron dot structure of ethanol. If you have still doubt in this thing, what it is, you can ask me. So let's carry on. A carbon compound A is having blah 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 blah, and identify A, draw its electron dot structure. Give the molecular formula of any two homologous series of A. So methanol, one is methanol. Give two molecular formula. C2, CH3OH, this is methanol, and then C3H7OH, this is propanol. That's it, done. These are the molecular formulas. C3H7OH, yes. You can also write down C3H8O like that. So this can be written as C3H8O. Okay, OH is the functional group anyway. So next question from this chapter. Now this is about thinking question. Can you think and can you understand? Let's see. It was asked in 2017. So, two carbon compounds. This is actually very good competency based question. Nowadays, these kind of question, one is X, other is Y, one is K, this and that, they are asking A and B and C like that. So try this one. Two carbon compounds X and Y have the molecular formula C4H8, C5H12 respectively. Which one of the following is most likely to show addition reaction? Okay. So, which one? And justify your answer. Have two carbon compounds have molecular formula C4H8 and C5H12. Okay, fine. Which will show. Okay, let's see. Also give chemical equation, explain the process of addition reaction. So you see C5H12 will be carbon, carbon. How to solve I'm telling. 1, 2, 3, 4, 5. H12. So here H2, here also H2, or for simplicity I'll write H2 here, H2, 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 H2. First carbon carbon chain, first of, and then H, 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 H. These are how many? These are 10. Okay, here 5 hydrogen, here 5 hydrogen 10, and here H and here H. So these are C5H12. There is no double bonding. So this can't show addition reaction. Now C4H8, carbon, 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 carbon. Hydrogen is only 8. So CH3 here, CH3 here, then here, here, here will be one hydrogen, H8 they said, and here also will be one hydrogen, H8. Now this carbon and this carbon has only 3 3 satisfied. So double bond. Now here we can add H2 and we can get C4H10. C4H10. It will become butane. Butane. It will become butane. Okay. So I'll show the exact answer. If you still have doubt, you can ask me. And in this next one will be more important question. So you have to try that one also. Here is the exact answer. You can take a note or take a screenshot. I will show the full question. This is the full question. Okay. And that's it. It's not that much hard. You can do it very easily if you practice a little bit. You should be happy for that. Yeah, you should be happy. So this was, by the way, a very nice question to be thinking based, competency based. Now another question is there. We have to complete the chemical reaction and we have to say what is the answer, how did this reaction happen. It's actually easy. So let's see. It was asked in 2017, not 2020. Anyway, try to complete this reaction. Don't worry, just you don't have to be exactly correct. Like here you can write down C2, CO2 and H2O plus H2O and complete the chemical equation. So yeah, CO2, H2O, but these are not balanced. So let's just balance it. So this is 2H2O. That's it. How many oxygen are there? There are 4 oxygen is there. So 2O2. That's it. Try this one again and this one again by yourself. I'll say the answer anyway, but you have to try. These equations are very good for practice. Okay, and I am going to show the answer. Yeah, here's the answer. So you can take a screenshot, but definitely you have to practice by yourself. Okay, and if you still get any doubt, you must ask me, because then only you will get clarity. So let's see the next question. There is atoms given in the next question that was asked in 2023, just 2 years back, and you have to identify those compounds. So try that here. Just identify those compounds. It's very easy actually. So easy. So try once, write down anything, and then I'll explain the correct answer. Okay, I'm going to tell. This one is propanone. CH3, CH2, CHO, CH3, CH2, CH3, CH2, CO, CH3. Identify the heteroatoms in the following compounds. Heteroatom means what is not part of this atom. Okay, so oxygen and chlorine. That's it. As easy. I said you have to try. You should be trying. Let's try the next question. Draw the structure of the following compounds. Butanoic acid. Differentiate between saturated and unsaturated hydrocarbons. Compound on the basis of their general formula. Yeah, that's a good one. Now, I'm going to give a question from 2023, and that will judge your total understanding of everything, what you understood and what you did not understand. So, can you say this one? It is in the, it was asked in 2023, and it is very important part of this chapter. Try this one. What are soaps? Explain the mechanism, like how do the soap work, the cleansing action of soap with the help of labeled diagram. Detergents are better than soap. Justify. So try it. I will write down the soap. Try. I will give a few seconds to you. So try that. And your times is up. So soap formula usually is CH3COONA. Okay, this. And it will form a structure that is a charged molecule, polar structure. So I actually saved one structure for you people. There is somewhere. Where are you? Soap, soap, soap. My God, how much explained? Yeah, here, here is the soap. So earlier I wrote CH3COONA. Remember? CH3COONA. So this is that Na part. This one. Okay. This will dissolve with water, H2O, and this will dissolve with grease, oil, whatever. That will help us cleaning action of the soap. Okay. Now I'll show the full answer for that question. So water soaps explain the mechanism of cleaning action. I just now explained detergents are better than soap. Why? Because soap form scum by reacting with magnesium or other salts, okay, calcium, magnesium salts, whereas detergents do not do it, and that is how they are better. So that is called missile formation, by the way. So I'll show the exact answer, full answer I'll show. You can ask me any doubt in that answer, and you should take a look at the answer completely. Here is the soap or potassium salt or carboxylic acid. This is sodium salt of carboxylic acid. Okay, and then cleansing action is there. Okay, dirty dirty cloth. Okay, not dirty anything, dirty cloth. Then it will be about the diagram, missile formation. So missile formation diagram I'm going to show you, people. You can take a note, you can take a screenshot. So here is the question, here onwards answer starts. If you have doubt, you must ask me. Here it's going on. So soap water becomes dirty, but the cloth gets cleaned. Okay, and then about detergent, why detergents are better? So it is better because it can work with hard water. Now, what is hard water? Hard water is when water has dissolved substance in it. So we call it sour water, khara pani in Hindi, so like that. Okay, so they work better than that. That's why detergent is very useful and good. Detergents have a stronger cleansing action than soap. But since it is stronger, we can't use detergent on our body. It will have a adverse effect. Now you understood? Now Lakshmi want to say something? Good, Lakshmi, you can say what you want. So you can definitely don't forget to take the screenshot, and let's bring Lakshmi back what she want to say. So where is just a second. She want to say about functional group. Okay, she want to say about allotrope and functional group. So let's have a look of the functional group and let's say what she want. But there is something else she actually did want to say. Hmm. So I'll show in a while. Before that, I'm going to give you next question and try that next question. You have to consider a few organic compound and you have to guess about it. So let's see. Try this question. And yes, this was asked in 2022. By the way, you are having very nice practice of this entire chapter. And Lakshmi messaged me just now that she want to know about what are these functional group. So let's see these functional group ones. Functional group, no. What we call that thing? Fullerene, graphite, allotropes. Allotropes. So let's see allotropes ones of carbon. We will have a recap of allotropes. So here we'll have a quick look. See the 3D structure of diamond. Okay, carbon will are arranged in 3D structure. Now fullerene, see ball-like structure or football-like, and graphite. This is graphite structure. Okay, so the graphite structure is like sheet one upon other. Okay. Now let's see what Lakshmi want to say about this thing, because she said I want to speak something, sir. So I have shown this thing. Now back to Lakshmi. So where are you? Let's just find her once. Yes, she came. Tell Lakshmi what you want.
Yo, yo,
Huh?
check the mic, C
Oh, you want to sing a song? Nice.
Four hands in the air, that's tetravalency. Sharing electrons, it's a covalent party. It bonds with itself.
Oh, earlier song.
Love chain,
Oh,
call it
nice.
catenation. It's running the game.
I like it.
Long chains, branch chains, even in a ring, that's why carbon is the undisputed king.
Nice.
From the diamond in your chain to the pencil in
But
your grip, it's
Lakshmi, can you?
all just carbon, that's the
Wow.
hot tip.
Nice, nice. But can you tell something about the fullerene and these allotropes of carbon? She's saying that yes, she can tell. So let's see what she want to say about the allotropes of carbon. Ready?
Is the same but different. See. Is the allotrope flow, CARBON. Same element but a different blend.
Okay.
Diamond's the king, hard and so tough. Locked in a 3D grid, can't get enough.
Okay.
Doesn't pass electricity, it's an insulator. Shines
Insulator?
so bright, it's a crystal creator. Graphite's the bro, in your pencil it's soft. Slips
Okay.
and it slides in layers aloft. It's
Okay.
a conductor, passes the current, see? Cause one free electron moves so free.
Nice.
CBSE, two forms, a total surprise. Just different structures right before your eyes.
Good. Nice. Very good. Amazing. I like it. Good, Lakshmi. Okay. So let's see the answer of that question. So that question. Yeah, nice. Good. Very good. Okay. So let's see the answer of this question. Consider the following organic compounds. So methane, ethane, propane. So CH3CO. Okay. Name the functional group. So this CHO, this is the functional group, and CO, this is the functional group. Okay, fine. And what they said, name the functional group and present in their compounds, write the general formula. So first is aldehyde. Okay, and name the functional group present in their compound. It's aldehyde. And then what they said, the general formula. So general formula contains CHO. Okay, so it should be, this is ethanaldehyde, this is propanaldehyde. Okay, aldehyde it is, functional group. State the relation between these compounds and draw the structure of any other compound having similar function. See, we can generally add one more carbon. Okay, and that's it. It will have similar functional group. One more carbon you can add. Okay, I am showing the complete answer, and if you still have doubt, you can ask. So here is it. Okay, aldehyde, general formula, compounds of aldehyde, groups CnH2n plus 2. So general formula is this, plus 2, no, 2n plus 1, because one hydrogen bond is attached with this. And these compounds show similar chemical properties and belong to homologous series of aldehydes.